Everybody, period 4 and 5 algebra. I couldn't be there today, so I made a little video of examples. Hopefully they could help out. Try to take notes. You could watch it twice. Once you can just pay attention. The second time you could take notes, and then if something doesn't make sense, please talk about it with the people next to you and help each other out. If you understand it, help each other out, and if you don't understand it, keep it real and make sure you ask questions. So, because we're stepping it up, we're going from solving absolute value equations to absolute value inequalities. So if you look at all these three problems, they're inequalities. We could see right here we have a greater than symbol. It's not an equal sign no more. The process is almost the same. There's just a little twist to it. Now these don't have equal signs. They have the inequality symbols. So remember that when we have absolute value, we could see all these are absolute value problems because of the bars. That when we think of that, we think of distance. And when we think of distance from 0 on a number line, there's two places that have the same distance. So like 4. A distance of 4, you could be talking about the location 4, or another point that has a distance of 4 away from 0 is -4. So when you think of distance from 0, there's two solutions. There's two places with the same distance. So we still know that because it's absolute value, we have two cases. So remember that. It's not just one case. So this would be an example of an easy one because the bars are already alone. If this was a wall, there's nothing else in the room with the bars. This would be an example, I would say, of a medium one, because if you look right here, the bars just have one friend in the room, and that'll be the -4. So you just have to get rid of that one friend first. And then this one right here will be an example of a complicated one, because if you look in the room, the bars have a few numbers with it. They have the -2 and the -4. So you would have to get rid of both of them. So we'll start out, remember that when you're working with any of these, that you want to make it simple. You want to get the bars alone first. Like in this one, they're already alone, so we're ready to start. But in this one, we would have to cancel out the -4. And this one, we would have to cancel the -4 and the -2. And then we could keep on going with our two cases. So first, you got to get the bars alone. All right, so right here, the bars are alone. So I'm ready to make my two cases. So it's x plus 3 is greater than 6. Case 1 is your positive case. And then case 2 is x plus 3 is less than -6. So case 1, leave the symbol the same. It's still greater than, and it's your positive case. Case 2, it's your negative case, but you're also switching the symbol. So that's the less than symbol. If I spelled out the word less, that's the less than symbol. Now I have two inequalities. So I'm going to solve each one. So I subtract 3. X could be anything greater than 3. And then I'm going to solve this one, -3. Here I have bills and bills. Be careful right here. A lot of people keep making mistakes. And that's going to be -9. X is less than -9. So now I have two numbers on my number line. Be careful, -9 comes first. It's an open circle. And then 3 would be over here, let's just say. And it's also an open circle. But I need to know if it's an AND graph or an OR graph. So I go back here. And if it's an AND graph, if it's a greater than, this is when it gets kind of tricky. We rotate the symbol. So if I have a greater than symbol, we rotate it clockwise. So the way that the clock turns, which is to the right, I rotate it once like that. And it doesn't look like an A. It looks like an upside down A. So it's going to be an OR graph. So this one is OR. So X is greater than 3. Anything greater than 3 would be 4, 5. Or X is less than -9. So anything less than -9, which would be -10, -11. So it's either one or the other. And looking at this graph, that's what an OR graph does look like. So we just solved this one, this absolute value inequality. Remember, absolute value is distance. Distance is there's two cases, but now we have an inequality. So I still have two cases. I have to know whether it's an AND graph or an OR graph. So I look back at this symbol. It was like this, and we rotate it towards the way that the clock goes, and it doesn't look like an A. If it did look like an A, then it would be an AND graph. So like if that's my greater than symbol, but let's say my symbol was a less than symbol, and I rotate it towards the clock to the right, the way the clock goes. And if I do it once, it does look like an A, so that would be an AND graph. So in this case, it's an OR graph. All right, let's look at the second example. Right here, I would actually pause and have you guys discuss this. And if you want, replay it. So pause right here before moving on to the next example. Okay, so the second example, the bars are not alone in the room, so we have to get rid of the -4. So we do the opposite, which is add 4. Add 4. So right here, we bring our symbol down. The symbol doesn't change. And then now we have the bars alone. Once the bars are alone, then you make your two cases. So x plus 3 is greater than 10. That's your positive case. Your symbol stays the same. And then x plus 3 is less than. You switch the symbol and you make it -10. So that one's less and you make it negative. Positive case, negative case. Okay, one, you keep the positive case, you keep the symbol the same. The negative case, you switch the symbol. Solve this. -3, 10 minus 3, 7. -3 minus 3, that's bills and bills. That'll be -13. And then we have two inequalities. So we have to know, is it this one and this one, or is it this one or this one? So we go back to where we got the bars alone. We don't go back to the original problem. We go back to where we got the bars alone. And then we look at the symbol that we have and we rotate it. So that's the symbol we have. It's a greater than symbol. And we rotate it like that to the clock. It doesn't look like an A. If it was an A, it would be AND. But it's not an A, so it has to be OR. So this is also an OR graph. -13 is first on the number line. It's an open circle. +7 is second on the number line. So x could be anything greater than 7, 8, 9, 10, 11. Or x could be anything less than -13, -14, -15, -16. So as we see right here, it does also look like an OR graph. So I've started to write the steps and I forgot. First thing is get the bars alone. So in this case, we had to do the opposite to get the bars alone. Once the bars are alone, make two cases. You have a positive case and a negative case, two different inequalities. Remember, the negative case, you also flip the symbol. And then you solve each. And then you look back to see whether it's an AND or an OR inequality. To see if it's an AND graph or an OR graph. And you determine that based on the symbol. Again, so if the symbol's like this and you rotate it the way the clock goes, that's going to be an OR because it doesn't look like an A. But if your symbol was like this, and you rotate it towards the clock, you're still rotating it the same way. That does look like an A, so that would be an AND graph. So far, we just see OR graphs. So right here, it would be good for you to pause, talk about it, replay it if you need to. This is one step different. It's not just two solutions.